You have surely heard about drones before. They started to gain popularity in the last years. They are now used in cinematography and videography. That being said, we can split them in two big categories. The first category and the most common one is assisted drones. The biggest brand is DJI. Everyone knows DJI. I have here Mavic 3 Cine. These drones are made for smooth footage, equipped with gimbals, big motors, big battery that can last around 40 minutes while capturing 5K footage, and they have around 5,000 mAh. These drones also have a lot of sensors that will protect you from potential crashes, and they also give a user-friendly setup for every pilot. Doesn't matter if you are a beginner or an advanced, they are very easy to use. These drones are also equipped with GPS modules that will make them capable of holding their position without big inputs from the pilot. They also have a lot of cool features like return to home, for example, but still, with all these cool features, maybe you're looking for something a little bit faster and with a more dynamic perspective, let's say. The solution for your problem is what we know today as FPV drones. These drones were designed to capture the most epic and dynamic footage at incredible speeds with style and moves like flips or dives. This being a different category, FPV stands for first person view drones. Pilot has an RC and a pair of goggles that will give him real-time feed from the drone camera. This thing will allow him to be more precise in speed, moves, gaps and maneuvers. But there is also a disadvantage at these drones. They have absolutely no sensors. So everything is basically manual and you need to learn how to control them. They require a lot of practice and knowledge for both piloting and repairing them because you'll have a lot of crashes, especially as a beginner. These drones also come in a variety of sizes, so I present the most important ones quickly. Consider the all-in-one is the 5-inch class, as you can see here. These are performing amazing, both at freestyle and cinematic stuff, being able to reach incredible high speeds. This iFly Nazgul 5 Evoke, the full-size GoPro Hero 12 on it. By the way, I have a full tutorial on how to build this thing on my YouTube channel. I think it has around 750 grams, very good for outdoor shooting. Next class, we have the smallest one here, Cinewhoops. These tiny toys are perfect for indoor shooting and tight gaps. They are super lightweight, making them perfect for flying over people at parties or different events. This Gepard System 25, for example, has only 245 grams. It's a naked GoPro 12, like on my 5-inch quad, but it's naked. It only weighs 39 grams compared to 150 grams. Now a bigger class. I got here an iFly Chimera 7 Pro V2. It's way bigger than this. This is the best choice for long-range missions, being equipped with a GPS module, but pay attention, this still works as a normal FPV drone and not a commercial one. Due to its size and bigger props, it is more stable in windy conditions, perfect drone for mountain dives. It is significantly heavier. I think it has 1.2 kilograms with GoPro on it, but it has a bigger battery. And this is a LiPo battery, by the way. This is a LiPo and this is a LiPo. Okay, so here comes the biggest problem between these two big categories. You want to have the video quality of a commercial drone, a lot of detail and room to color grade your footage, clarity and whatever, and also the dynamic perspective and power of a FPV drone. Action cameras like GoPro could never capture the image of a DJI drone. How to get both of them? I have a simple answer: Cinelifters. The biggest class of FPV drones designed to carry heavy payloads without sacrificing the capabilities of a freestyle quad. You can make flips, dives or whatever with a red Komodo on without realizing that the whole drone has around 4 kilograms. That's why today I want to build and show you how I build an entire Cinelifter. 9-inch TBS Honey Badger. So I want to show you what parts I'll use to have a better understanding of what I'll do. For motors, I went with Garcin 30-15 with 920 kV for a lot of torque and power. As you can see, I really like the color. Okay. FC motor Velox F7 V3, 8 motors output. Flight controller is the unit that will process everything. So basically, without this, you cannot fly the drone. And it's very important for a Cinelifter to choose a flight controller that has 8 output motors. For ESCs, 2 Dayton Mamba F65 4-in-1. I have a spike absorber. This is how it looks like. I have pigtails and also 2 albatross antenna. They are long enough to capture a lot of signal. TBS crossfire receiver. This is how they look like. For the video transmitter, I'll go with the DJI O3 Air Unit. I also have the GPS. This is a Maytag M10. Capacitors, propellers. So this is my 7-inch quad and this is my 9-inch propeller. It's way bigger. As I said before, this is a Honey Badger TPS 9-inch frame, so this is how it looks like inside. These are the motor plates, these are the arms, screws, plates, and yeah, I'll put it right there. This is an X8 drone. If you want to carry heavier payloads, you need power. And how do you obtain that power? You can either put bigger motors, let's say 4 bigger motors, or you can put 8 motors, one on the upside and one downside. And that's exactly what this frame is designed for. Top plates. This is the battery plate. Triangles are for straps. These are the arms. You can see 8 millimeters in thickness. These are the motor plates. Here are exactly 8. They are coming like that. We also have spaces for screws here. And also we have a lot of tiny screws. Yeah, this is how a Cinelifter frame looks like. This is the top plate, the plate that will come on top of everything. After that will be this plate, something like this. And in this gap between them, there will come the arms. Where electronics comes is between this and this plate. This is the front, yeah, and this is the back, this is the front, this is the back. I first assemble these pieces. Now I think I should install the arms. Let's see if this, yeah, this fits perfectly. Okay, so these are the screws for these big holes. If I come like this, the arm like this, that's one, and this way. Okay, let's try to put this now. What exactly are these for? Okay, I think I know what are these for. These holes are made for this ESC to fit like that. And these holes are made for these screws to fit here. And also they have some holes here. So you can insert this kind of screw and to also have room to place it here. That's kind of cool. And this. These long screws. I'll choose this one. This looks better. I think maybe a 3. No, 2.5 maybe. Nice. It looks pretty good. Locked in. Now the one secured. These are pretty tight here. That's it. Okay, whew. What I can tell you after I nearly killed myself trying to install these screws is that it's durable. Next step, install the motors on motor plates. First of all, let's clean a little bit this mess. We have, as I said, RC motors. Yeah, you see them. They are amazing, man. So nice. We have the motor plate. I'll put some Loctite and now. Yeah, it's pretty good. This is how it looks. Okay. Nice. We have all 8 motors. Let's take the frame back here. And now I think we can install them right on the arms. Whoa, that's perfect. It fits amazing. So you see, I have one on top and one will be on bottom like this. 4. This is it. 16 bolts. One here. Tighten the bolt. That's how 2 motors are supposed to go. Looks good, right? I'll come back after I install all these bolts. I have finished mounting the motors. It's really big and it looks pretty good. What's next? I'll prepare the ESCs. These 2 Mambas, they look like this. Fancy. This, perfect. got the ESCs. Now, what I want to craft is the power cable. Let's explain you a little bit how this drone will power up. So basically, we have negative and positive for both ESCs and for the battery. Let's find the battery. This is a battery that I can fly on my Cinelifter. It's a 6S 4500 mAh. These two will connect in parallel. Being connected in parallel won't affect voltage, so I will make a cable, one part to connect to the battery and then to connect each ESC. I found two connectors. They have pretty big cables. I'll use them to craft my connector. One and two, and here we go. We have one. I'll take my flux. So this is our connector. Spike observer. Let's take it out. Okay, that's one. And that's the first capacitor. Let's repeat the process for this one. Good. I will start soldering ESCs, black wires. Pretty solid here. Here we go. As you can see here. Okay. This spike absorber. The spike absorber basically cuts off high voltage spikes, protect your electronics. Nice. This is it, I guess. Very small. And it works. So these are the ESCs right here, connected in parallel. Now each capacitor, just like that, here. How the circuit looks right now. This is the connector, this is the spike absorber. These two are DSCs together with capacitors. Plug in cables for ESCs from the flight controller. We should have here what we need. Looks amazing. See here, place two. Looks incredible. So these two cables are plug-in connectors for ESCs. It's pretty cool that this flight controller already has two output ports for two 4-in-1 ESCs, one for digital system, and yeah, right here. Where's the second one? This is a setup. We'll put the flight controller back for the moment. And here is the drone. Now I will install ESCs just like that. Top motors on the top ESC and bottom motors on the bottom ESC. At this point, I feed them through this gap. And this is it. First motor port, second one, third one. Looks nice. Here we go. This is the electronic part for the motors. They are all connected right now. That's amazing. Let's see what flight controller has to offer us. And here is our masterpiece. Just like that. Pretty small. Rubber parts. These small rubbers help a lot with vibrations, especially for a Cinelifter. Perfect. Now I have The flight controller, I have 2 wires that I need for both ESCs. Next is VTX, DJI O3 air unit. And this is the air unit. Pretty awesome. I have the cable already installed. What I want to see, if I can pre-install it on my flight controller. We have red, black, that looks perfect. And I need to remove the cables. I can connect it straight away to my flight controller and my air unit, but I will remove these 2 cables because I'm not using DJI remote. I use a different RC control link. Brown is out right now. I want to connect GPS, and I have here this beautiful GPS module. We already have a cable here, so this basically doesn't matter how it goes here. Cut these wires. The yellow one. And with that being said, we have installed the GPS module. Just the cable a little bit. Let's take out receiver. The antenna. I will solder it right here where I have ground, 5 volts, RX1 and TX1, so it's basic wired 1. Volt wire, white wire, which is the RX for receiver and TX for the light controller. And just like that, we have our receiver installed. I insert it like this, and I also connect the antenna. This is the flight controller connected with receiver. Now, we should install the flight controller exactly like this. So now we have flight controller, the whole setup for the ESCs, cables. We can go to the lower part of the drone represented by this plate. I need to discover how is this going to fit here. Take this ender and I will put it right. The air unit also have these 2 antennas. Get it out. That's perfect. And this is the original antenna. These pigtails, one here. And after that, put back this cover, put them back together. I have the pigtails. Let's put the drone in a way that I can spin the motors and I'll start testing it. Let's plug into the laptop and let's open Betaflight. Okay, it's an Octo X8. Save and reboot. This is back, this is front. Let's plug in the battery. Let's try to move motors. That's really nice. Everything is working just fine. Let's also set up the order of each motor. Let's see. Back, left. This is front, left. This. Okay. This, back and front. Save. Motor direction now, individually. Okay. Reverse it. Reverse it. Fourth one. This one is okay. Perfect. So every motor spins in the right direction. Transmitter, TVS agent, hit bind. If I am gonna power up the drone, because it's a brand new receiver, it should go right away in binding mode. And as you can see here, there's a receiver. I'm updating the receiver right now. I have image on goggles. Now go in Betaflight, connect it again, receiver tab. I need to set it crossfire, save and reboot. As you can see, I have movement and everything seems to be perfect. The modes, select the R mode, angle and horizon from this switch. Hit save, and here's the moment of truth.
Telemetry lost. Telemetry recovered.
That's it. I'll take off the battery. This is it, guys. Drone works pretty well and everything seems to be fine.
I also went out to test it in the field to see how it performs. Here I'm setting up the launching pad to have a clean spot for takeoff. And you can see a dog here. And the big boss equipped with the Sony ZV-E10 Mark II. And the second camera for a third-person angle. Plug in the battery and hope for the best. That's the setup. Enjoy! I brought a friend with me to capture the Cinelifter from an FPV perspective and see how it behaves in different situations, how it responds to stick inputs at different altitudes, speeds, and when flying through tighter gaps. We wanted a clear idea of its stability, responsiveness, and full throttle performance compared to the 5-inch quad. And as you can see, it performs really well, even in dives and more aggressive moves, and the rig stays stable and locked in. Overall, the results were very promising and gave me confidence for future shoots.
After many hours of hard work, this is how it looks like. Definitely worth it. I'm very proud of this build, and yeah, I hope you enjoyed this tutorial. If you like my content, subscribe, like my videos, and share them. I would appreciate it a lot. And that was my Cinelifter build. We'll see you next time.